Okay, so the real goal of section 13.1 is to start proving trig identities. So there are two steps that we're going to do in order to do that. We're first going to rewrite everything in terms of sine and cosine. And then we're going to pick one side of the identity and we're going to work with it. We're going to rearrange it and change it until we get the other side. So we're going to do that by working with this following identity. So we're going to show that cotangent of x plus tangent of x equals cosecant of x times secant of x. So first we've got to pick which side we're going to deal with. So let's pick this side to deal with because it has more things to work with. It has two terms, one and then two terms over here, instead of just the one thing that's hanging out over here. So that's usually how I pick. It's got more stuff to deal with. So let's rewrite these things in terms of sines and cosines. So cotangent of x is the reciprocal of tangent, which means that it is the cosine of x divided by the sine of x. And we know tangent of x is equal to sine divided by cosine. And that's supposed to equal cosecant of x times the secant of x. We'll just put that little multiplication symbol in there. Okay, so I have two terms over here on the left, and I only want one term on the right, so that means I need to add my fractions together. And in order to add fractions, we have to have a common denominator. So in order to make sine and cosine the same denominator, I'm going to multiply them together. So I'm going to have cosine of x being multiplied into the first one, which is going to give me cosine squared of x in my numerator divided by sine of x times the cosine of x. Plus, then I'm going to go over here, and I'm going to multiply cosine of x by sine of x to get the same denominator, which means I also have to multiply the numerator by the sine of x to get sine squared of x over sine of x cosine of x. And again, that should still all equal what we want over here on the right side. Now, we have to remember to look out for different things that we already know. So, for instance, we know that the cosine squared of x plus the sine squared of x is equal to 1. So we might want to be looking out to see if that happens because we have a cosine squared x here and a sine squared x here. So maybe something will happen. Who knows? So we've got cosine squared x over the same denominator and sine squared x over the same denominator. They have the common denominator, so now let's just squish them together. We get one big fraction. So we get cosine squared x plus sine squared x. Hey, look, that looks familiar. All over that sine of x, cosine of x denominator. And that still equals cosecant of x times secant of x. Okay, so now we're going to take that we have this whole thing showing up. And we know this equals 1. So we're going to substitute the 1 in, and we're going to get 1 over sine of x cosine of x. And we want to make sure that that equals cosecant of x times the sine of x. Oh, not sine of x, secant of x. Whoops. Okay, so when we have fractions being multiplied together, we can then split them apart. So we can say that this is 1 over the sine of x times 1 over the secant of x. Hopefully you can see where this is going now. And we want to know if that equals cosecant of x times secant of x. But we know that 1 over the sine is really the cosecant of x. And we know that 1 over cosine, oh my gosh, made another typo. Go back and fix that. So this was supposed to be 1 over the cosine of x. Yeah, I probably had you a little confused for a little bit, but hopefully now we're back on track. So 1 over cosine is in fact secant of x. And hey look, it's the same thing on the other side, which means that we are all done. The nice thing about this is that you always know when you're done because you have the same thing on one side and on the other side. So that's how you prove two trig identities.